Alright, today we're going to talk about solving multi-step inequalities. The first example of this sort of thing I'm going to give you is 3 is less than negative 5 and plus 2a. So when we talk about multi-step inequalities, there could be a lot of things that make them multi-step, so to speak. It could be combining like terms, it could be distributive property, it could be fractions. It's going to be something that makes it have more than the typical number of 1 or 2 steps, adding and then dividing or subtracting and multiplying, like we've seen before. So in this one, this is actually still a 2-step inequality, but the first step is a little different than any other 2-step inequalities that we've done so far. What do you notice about this side of the equation?
There's both.
Yeah, there's 2 terms that both have a variable. And when you see more than one term with variables, I want you to think back to that balance scale, right? And even though now it's an inequality, so the balance scale is tilted like this, right? This one is less than this one. It's not actually equal. We can still do the same thing of taking something off this side and taking something off the other side. Or, in this case, we don't need to take anything off this side. All we need to do is combine these like terms. Combine our ends to get one end term. Okay. So this is going back to combining like terms. If you remember that lecture and that practice that we did, we have to combine on this side of the equation negative 5n and positive 2n. Yeah, so if I have negative 5n's and I also have 2n's, think about each one. Each negative is going to cancel out one positive, right, on our balance scale. How much do we have left when we combine negative 5n plus 2n? Yeah, we have negative 3n left. And now this looks like a problem that we've done before. So now we would divide by negative 3. 3 divided by negative 3 is negative 1. What do I have to remember to do? Switch because I divided by a negative. The negative 3's cross out. N. Now I'm going to rewrite this as n is less than negative 1 because that's going to be easier for me to graph. So there's my answer. And here's negative 1, 0, negative 2 on the number line. And I'm going to draw a hollow dot because it's not equal to. And I'm going to point my arrow that way, just like the last one. So from here on, this is stuff that you guys are familiar with. But what you're going to start seeing, it's nothing new, actually. It's just going back to things like combining like terms, distributive property,
So
etc.
you subtract the 2 variables.
We combine these 2 like terms, yeah. So in this case, it's like negative 5 plus 2, n.
And you're going to subtract that, it's going to be negative 2, okay.
Negative 3, n. Yeah.
So instead of adding, you're going to subtract. Right?
Well, we are adding, but we're adding a negative number to a positive number,
Oh, that's going to go, okay.
which is subtracting.
Yeah.
Yeah.
So if they're both positive numbers, then you're going to, like, if 5's a positive, it can be 7.
Yeah, if this had been just like that, it would have just been 7.
Okay.
Exactly. Alright. So combining like terms, that's one type of thing you might do. Here's another one that's slightly more complicated. But not too much. So in this case, we have our like terms on this side of the equation. But there's also a number in between. Does that matter?
No.
What rule do you guys know that would let you get these next to each other? that would let me commute this over here. It's called the commutative property, right? So this is the same thing as 6x plus 6x plus 2 is less than 2. This is using the commutative property of addition. I can move my 6x here. If it had been a minus 6x, I would have had to move the minus sign with it. Right? So commutative property only works for addition. Right? Like 2 plus 3 equals 3 plus 2. But 2 minus 3 does not equal 3 minus 2. The commutative property lets me move stuff around. As long as I keep the negative sign or the minus sign with it, I can move it around. So if this had been 6x plus 2 minus 6x, I still could have moved this over as 6x minus 6x. I still could have moved those together. I just have to keep the negative sign with it. Alright, but that's not the problem we have. The problem we have is now 6x plus 6x plus 2 is less than 14. What do? There's actually a couple options to do
You
now.
subtract 2.
Yeah, so I could subtract 2 right away. I like to typically combine like terms first. So before I start subtracting from both sides or anything like that, I'm going to try to get each side as simple as I can.
Okay.
So I'm focusing in just on this side of the equation. 6x plus 6x, oh, that's just 12x plus 2. There's no way to combine that because these are x's and this has no x. And then I'm going to focus just on this side. 14, there's really no way to simplify 14, so I'm going to leave it as it is. Now I'm going to go back to what we said, subtract 2 from each side. 12x plus 2 minus 2 is 12x. And then 14 minus 2 is 12. Now I need to divide by 12. Do I have to flip my inequality?
Yeah.
Dividing by 12, it's a positive number, so I don't have to worry about that. 12 divided by 12 is 1. X is less than 1. Box my answer, do a number line, 0, 1, 2. It's going to be a hollow dot because there's no equal to, and it's going to be pointing that. So these work out just the same. Once you get to these last few steps down here, it's just the same as the types of problems we've been doing. Usually it's going to be the first couple steps that are different. What I would recommend is thinking about it almost as two separate problems to begin with. I think of it as, what do I do to simplify this side, and what do I do to simplify this side? So what am I doing here, what am I doing here? And then remember that balance scale. That's another key point. And then simplify it. Alright, what if I have this one? Negative 3 minus 6 times 4x plus 6. Ooh. Ooh. There's a lot to do here. Can I combine the negative 3 and the negative 6 right away?
No.
No. Good. I'm so glad you said that. Because this is multiplied times all of this. And it's not just the 6 that I'm multiplying, it's the
4x.
negative 6. Right? So I'm going to keep my negative 3. And I'm multiplying negative 6 times 4x is negative 24x. So be super careful with problems like this. Because if you lose track of that negative, or if you forget what's multiplying and what's adding, it's easy to do a step in the wrong order. But just remember PEMDAS, right? Multiplication comes before addition and subtraction. So I have to multiply this before I can add these.
And that's the only
All
time you
PEMDAS.
could put a positive number, I mean, you could put a number with a algebraic number, or that's the only time.
Well, whenever you're multiplying, yeah, you can combine.
Okay.
Right.
Yeah.
A negative 6 times positive 6 is negative 36, greater than negative 1. Well, I multiplied by negative 6. Do I need to switch this?
Yeah.
Let's think about that. Did I actually do anything to this inequality?
Oh, no.
I didn't multiply both sides times negative 6. So I don't have to worry about switching. All I did was simplify this side by multiplying negative 6. If I multiplied both sides of this by negative 6, that would be different. Okay. Distributive property. I got this. Now what do you notice about this side of the inequality? Okay. So actually that's a really good thing to notice. If they're all negatives, can we just multiply by negative 1 and make this a lot simpler? That would be so easy. Watch. If I multiply times negative 1 to everything. I also have to do it on this side though, because I can't just change one side of my inequality. I multiply through by negative 1. Negative 1 times negative 3 is 3. And then I'm going to have plus 24x plus 36. I now have to switch the direction of my inequality because I multiplied by a negative. So that's less than 111. What else can I do on this side of the inequality? Usually I want to just have two terms. I want to have an x term and a constant term. Why do I have three terms here? If I have more than two, I know I can combine something in this case. What can be combined on this side? Can I combine the 3 with a 24?
No.
No, but I could combine. So I'm going to rewrite this using my commutative property. 24x plus 3 plus 36 is less than 111. If you hadn't thought to multiply through by negative 1, not a big deal. You would just have all negatives still. You would have negative 3 minus 36, which would be negative 39. It's totally fine to not do this step, but I really like that we did. I think it's so much easier to add than to just deal with positive numbers. So now I have 24x plus 3 plus 36 is 39, is less than 111. Okay. Subtract 39 from both sides. 24x is less than, and then I would do this over on the side, right? 111 minus 39, draw a line, let's see, we're going to have to borrow from there, 2, and then 10, so 72, so 24x is less than 72. Now what do I do? Divide by 24. X is less than 3.
How do you come up with these kind of problems?
And I'm going to have to graph this. Here's my 3, here's my 4, here's my 2. I'm going to do a hollow dot pointing that way.
How do you come up with these kind of problems?
I know, right? It's amazing that they work out to these positive
Exactly. You gotta
integers
think
all
the
the
whole
time.
way.
It's not always the case in real life, right? Things aren't always quite so easy at the end. Good work, guys. I love that you saw the negative 1. You saw that they were all negatives.
Yeah.
That one was long.
I could have never done that one.
Yeah, that one, you could have, and now you could totally do it on yours, right? So we're going to do another one very similar to that. We're going to do 167 is less than 6 plus 7 times 2 minus 1. Okay. So this one's very similar. I can't add the 6 and the 7 because the 7 is multiplied times this. PEMDAS says multiply before you add. That's right. So 167 is less than 6. And I'm just going to distribute the 7 through the parentheses. So it's a positive 7, so 7 times 2 is 14, plus 14. 7 times negative 7 is going to be, this negative stays there, or minus 7, minus 49. Okay, now I don't even need to use the commutative property. I can combine my 6 and my 14, because neither one of them has a variable, right? So I have 167 is less than 20 minus 49r.
Subtract, add 20, right?
Well, we want to subtract 20 because this is a positive 20. The opposite of that is minus 20. So I have 147 is less than negative 49r. You just have to remember that that minus sign now turns into a negative. Because it's like 0 now, minus 49r, which is negative 49r. And then, yeah, now I'm going to, this is a little hard to see it. Now I'm going to divide by negative 49. I'm dividing by a negative. Alarms are going off in my head. Why?
Because it's going to switch around.
It's going to switch around. And I believe that 49 goes into here exactly 3 times. But a positive divided by a negative is a negative.
Oh, negative.
When we're multiplying and dividing, one negative is going to give us a negative answer.
You got to turn
And I'm going to switch around this sign.
You got it.
Negative 49 and negative 49, those cancel, I just have r. I'm going to switch this around to say r is less than negative 3. Rather than negative 3 is greater than r. It's the same thing. Just writing it with r first. And the reason I do that is so that my arrow points in the direction that I want it to go. And then I graph it on this number line. Negative 3. A hollow dot, because there's no equal to, pointing left, gives me the graph of that.
Perfect.
You guys followed that?
Yep.
That went pretty quick,
Yeah.
right? But once you start doing more than one of these, you've seen these rules before. It's just using them now with inequalities rather than with flat out equations.
Why did they call it inequalities?
Because they're not equal. They're unequal. Okay.
That's our homework.
Your homework is this sort of stuff. Now I'm going to give you a fairly complex one now to do together. So this one is negative. Let me get a new marker. Negative 2 times 5 plus 6n is less than 6 times 8 minus 2n. So up until now, we've just been dealing with simplifying one side of our inequality. Now we have to simplify both sides. So it's sort of like two problems in one in that sense. And then you're going to want to think of that balance scale again. So let's just look at this side. How can we simplify this?
Oh, by multiply negative 2 and 5.
Yeah, distribute my negative 2. So I'm going to get negative 10. Is it going to be plus 12n? Or minus 12n? Which one is it gonna
Minus?
be?
Wait, no.
Why would it be minus? Why do you
Because
think-
you're going to have a negative number when you multiply the negative 2 by 6.
Yeah, so I'm going to have a negative number. So it's plus a negative, which is just minus. So I have to remember that this negative goes with me. It goes with my 2. Okay. Is there anything else I can do to simplify this side of my inequality?
Yeah.
there any like terms that I can combine?
No. No, there isn't.
Any more distributive property? Not really. So I'm going to say, okay, now I'm done with that side for now. Now let's just look at this side. What can I do to simplify this side? Well, I can do the distributive property again. So 6 times 8 is 48.
48. And then 12.
6 times negative 2n, so that's going to be negative 12n. This is kind of interesting. It's kind of interesting. Yeah. So think of our balance scale. Negative 12n over here and negative 12n over here. I want to get them off of one side.
Subtract the 10.
So I'm getting rid of the negative 12n. In other words, what I'm doing is I'm adding 12n plus 12n. But wait a second. What just happened? I tried to get it off of this side, but it also disappeared from this side. And now it just says negative 10 is less than 48. Okay, so there's two things that can happen here. Is this true? Is negative 10 less than 48? Yeah, it is. So then that means anything that I plugged in for n, this is still true. So there's a solution. And the way I would graph this is I would just draw a number line. 0, 1, 2, negative 1, negative 2. And it's just an arrow going both ways. Right? N could be anything, and negative 10 is still less than 48. There's not an n involved in that, right?
That's so cool.
So everything is my solution to this equation.
0,
Okay.
5.
So this is kind of a special case. And now I want to do one last problem. I know we've done a lot of problems together today, but you're going to love me when you take a look at your homework and then look back at your notes. So let's do this one. 3 times p minus 3 minus 5 is greater than negative 3p minus 6. All right, let's take a look at this side of the equation. How can I simplify that? Can I combine my p and my negative 5p? Why not? They're both p's. One of them is in a parentheses. Parentheses comes before I can add them. So I'm going to do my distributive property first. 3 times p is 3p. 3 times negative 3 is negative 9. And that doesn't affect the 5p because that's outside of the parentheses. Is greater than negative 3p minus 6. Okay? I'm still just looking at this side. How can I simplify that? Oh, commutative property. 3p minus 5p minus 9. So I moved the whole plus negative 5p over here and the plus negative 9 over there. Do that. And that's going to let me combine these two terms finally. So what is 3p minus 5p? Negative 2p. Minus 9 is greater than negative 3p minus 6. What do you guys want to do next?
We're going to minus 3p by minus negative 2p.
Yeah, we're going to have to somehow get all our p's on one
Plus-
side.
plus
So,
p.
right, so maybe we add 3p to both sides,
Yeah.
plus 3p. That's going to get rid of that p and add 3p over here. What is negative 2p plus
1p.
3p? 1p minus 9 is greater than
6.
6. Then what do I do?
You're going to add 9.
Yeah, add 9 to both sides. I'm forgetting to do that. So, plus 9 greater than. Negative 6 plus 9 is
Greater than
positive 3.
15.
Well, it was a negative 6.
Oh,
Right?
okay. 16.
So it's like 6. It's like a 9 minus 6 is another way of saying this. P is greater than 3, which means I'm losing juice in my marker again. Which means here's 3, here's 4, here's 2.
That's gonna be.
Oh yeah. It's a big old piece of pizza. Went from something really big down to something really small. That's a big piece of pizza. Okay, so just to quickly review, you're simplifying each side, and then you're trying to get P alone. When you have P on both sides, like we did here, right in this step, we have to add it to get rid of it from one side. Just like on our balance scale, right? Whoosh. And then whoosh. Do the same thing to both sides of the equation. Okay? All right, good work, guys.